Hi everyone.
Hi, everyone, and welcome to another edition of the Kedro Coffee Chat. I'm Rashida, your host today, and I'm thrilled to announce our speaker, Elena, software engineer on the Kedro team. She's hosted multiple coffee chats before, and today she's bringing one of the most exciting talks yet, building a GenAI powered chatbot using Kedro and LangChain. Now, before we dive in, let me share my screen and share with you updates on what the Kedro Coffee Chat is. So, we host these sessions every other Friday, streaming live on YouTube and LinkedIn. In case you haven't followed us, please be sure to do so. We typically cover existing and new Kedro features, upcoming Kedro plans, and other exciting topics. And if you have something you would like for us to cover, also let us know. Now, after each session, we open to Q&A, so you can drop your questions on the chat. And if you have additional questions, you can always ask them in our Slack questions channel. We have two rules. There's no such thing as a silly question, so please ask away. And live demos can sometimes fail. So if that happens, please send positive vibes to our presenter. With that, without further ado, we can get started with our chat. Let me remove myself and let me hand it over to you, Elena.
Hello everyone. It's nice to be here again, and that's the first time I'm on this side where I'm presenting the stuff rather than hosting the coffee chat. And I would like to start from explaining why do we want to do this session today, and why do we want to speak about Kedro and how you might use it with your GenAI application. So first of all, like what I'm showing you is our documentation page. We're really proud of it, and as a benefit, it was the part of the training subset for all language models. So if you go and try to play with like ChatGPT and ask questions about Kedro, you might get some reasonable answers. But sometimes what we notice, like if you go deeper and try to ask very niche questions, you might get like the answers that you are not satisfied with. And the good news, except of questions, except of documentation, we also have a question channel, which is our support channel where we every week uh, uh, some of our team members is trying to answer all the questions for the users and give the support. So we want to clarify and we want to check how can we improve the question answering use case for language model if we also use this data, not just our documentation. And the other thing is that a lot of people were asking so far whether Kedro is the right tool for GenAI. How can they start? What are the difficulties and what applications can be served with it? So in order to answer all these questions, we want to showcase you the use case where we'll do retrieval augmented generation. Uh, for those who are not familiar, this means that when your language model answers the questions for a context, it will use some document which is retrieved from the vector store that you prepare in advance. So the information might be injected into the language model prompt, and the quality of the response should be improved, hopefully. Um, we will not follow this specific tutorial, but I'll just quickly explain you how it usually works. So imagine you have the set of your documents and you want to use them as a context for your language models. Obviously, you won't inject all of them because then you'll make your prompt very long. So you need to build a solution to create a pipeline that checks and selects this specific document, which is relevant to your question. For that, you do some pre-processing steps where you usually vectorize all these documents and store them in as embeddings in the vector store, which can be used later on to search the relative documents depending on your question. And then in the language model loop, uh, before answering the question to the user, you'll use the same question coming from the user side as a query to your vector store, which will help you to retrieve those documents and use them as a prompt to your language model. So typically for this use case, the only thing you need is like the collection of data. Luckily, we have our Slack question channel with multiple questions and a lot of answers from our team members. And the only thing you need is the language, your vector store that you'll build based on it, and the language model. But I want to follow all the trends. So instead of making this use case, I'll use the agent, which will learn how to look through my vector store, and then depending on the question, it will query it, retrieve the document from it, and answer the question based on this retrieved context. So that's the setup, and let's dive deep into the implementation itself. For this demo, I'll use the LangChain to work with my language models and the vector store called Deep Lake Vector Store. And that's a very nice tool for those who are starting working with vector stores, because it's very easy to understand. It has like a lot of functionality to create the vector store based on different embeddings. It's also integrated with LangChain and other existing tools. I'll start from showing you the pipeline overall. For this, I use my Kedro tool, which is the tool for visualization Kedro pipelines. This is how it looks in general. So it's quite massive compared to the very small pipelines which we usually show in demos. And it has two main parts. The first one is the part where you create your vector store based on your dialogues from the Slack channel. And then the second one, you build your agent retrieval augmentation pipeline, where this vector store is used as a tool for querying, and this tool injects it into the language model, so it knows how to call it. And as a result, I want to show you the comparison between the normal language model output and language model with injected tool, meaning the agent with the context that we retrieved from the vector store. So I'll go straight to the implementation. Here on the left-hand side, you see like the usual Kedro project split on the config, data, documentation, notebooks, and source. As I said, we will focus on two pipelines. With the first one, my goal is to create the vector store. So here are my pipelines and nodes. I'll show them that way. Pipeline is not that long because I'm starting from already cleaned dialogues. By the way, here's how they look like. I've already spent time to clean them up a little bit and save without any like information that I want to inject into the language model, such as like user names and so on. So here are my like starting points, and like the typical Slack dialog will look like that. Well, you'll see the question and users answer to them. Through my, no, it's not smart to do that, but anyway. The first thing that I want to do, I want to convert my JSON files into the plain texts in order to transform them to embeddings. I want to clear up some like and remove some usernames and things that I don't want to be in the vector store because they're not needed there. For that, I just use the format dialog nodes, which does all this job for me. And the second part is to create the vector store itself. For the vector store, I need the object, like the vector store itself, where I'll store the data, I'll need the my embeddings. In order to get the embeddings, there are different ways of how you might do that. You might, for example, just use the integration part of your vector store with LangChain, where you inject your model that is going to produce the embeddings, and vector store will do it for you. But since I don't want to spend a lot of resource on generating those embeddings, because I don't even know whether all of them will be needed at my vector store, so why would I use the expensive embeddings? In order to replace that, I'll use the simple ones, because I suspect that for the simple use case, they might be enough to do the pre-selection of these dialogues in the context. And that's why I use the hash and vectorizer. So basically, my embedding function will input my texts, the embedding size, which is the parameter, and it will produce the embeddings based on the hash and vectorizer. Another good thing for this is that I don't need to store any dictionaries, anything else. I'll just need to know the size of my embeddings, and I can reuse this function everywhere. So that's how I create the embeddings. I transform my dialogues into text. I know how to create embeddings from text. And for metadata, I'll only use the dialogue ID, though in some more complex pipelines, it makes sense to inject some extra information, which can be further used to query your vector store too. So for example, you might add some metadata with sentiment analysis, where you know whether this dialogue was helpful to users or not. And then at the time you retrieve your embeddings from the vector store, you already know whether are they good or not as a context for a model. Here we don't do that. The one more important thing is how I exactly interact with my vector store. Because in Kedro, the important part is how you set up all your data sets to input and output the data. In order to deal with dialogues, I use the partitions incremental data sets. That's the option to deal with data sets consisting of multiple files. I use the JSONs because originally I saved my dialogue there. And I need something to interact with my vector store, and we don't have such data sets. That's why I've created my own, which is very simple, because the only thing that I need is to be able to load this vector store and add the embeddings later on. So the dataset is responsible just for loading and saving. And since saving is done automatically with the deep lake vector store, my save function will not do anything because and I use this use my data set that I've created like that. It lives next to your pipelines. I've put it in the datasets folder there. And the important option that I want to have is the whether I override it or not, because for the first pipeline, I would love to create it from scratch. And then when I run my agent, I want to use the one that is already saved, so I don't do it once again. Let's see how it looks like when we run it. So I can just run this pipeline without agent yet. So I specify the pipeline, the name of my pipeline, create vector store. That's what I do. Okay, something is running, which is already a good sign. Here we go. So now I see some outputs from like pre-processed dialogues. I see the output from my vector store object telling me what is the structure of my vector store. And if I go exactly to the place where I want it to be stored, so it's here, I'll see like the object created for me. That's that's what I wanted to have so far. And the other part is the agent pipeline. uh, in order to start with it, I need to have my vector store, and I also need to have my embedding function, because at the time I'll query it, I need to transform the user query into the same embedding so that can be used for a search at my vector store. Then I'll use this vector store and the embedding function to create a tool, where tool will be the mechanism for my agent to interact with the vector store. And I inject this tool into my language model to create an agent. And on the other side, I'll have just the plain language model without any agent things and tools injected. And at the end, I'll create the interactive loop where I show you how to query them together and what's the difference in their outputs, how the quality can be compared with them. So let me go back to the implementation. And now we're done with the vector store pipeline, and we want to let me this now. We want to look at how our agent pipeline looks like. It's located on the pipeline folder. Here it is. So first of all, like one of the main questions when you create the agent-based pipelines, and basically pipelines where you need to pass objects from one node to another, is the question is how you do that. Because in Kedro, that's what's expected from you is that inputs and outputs are from your nodes are either nodes or are either data sets or parameters. And the requirement for the default like data set that it should be serializable. And sometimes when you create those objects like agents, language models, and so on, they might not be. But that's not the problem for Kedro at all, because we have the tool like that, allowing you to redefine the default object creation. This is called like that. Yeah. Which is called like dataset factories, and there is like an explanation how you can redefine your default dataset factory. That's how it's called, how to override the default dataset creation with dataset factories. What it means is that you might decide like what will be the default type of your dataset if nothing is specified in your catalog. And that's exactly what we want, because we will use it to pass objects using the reference without any serialization. Meaning that once we did this, we don't really need to create any data sets for non-language model, either non-lines, any or agents or anything else that you want to bypass from one node to another. That's the first thing. The other thing is like the trick that you might also use, as I do with like the vector store. So for the first pipeline, I want it to be set as override true, because if I recreate it, I don't want to extend it with embeddings. I want them to be created from scratch. And then once it's used in the agent pipeline, I want it just to be consumed as it is without recreation. Another good news that we have actually the data sets to interact with LangChain models. This data set is, I also use it in my pipeline to initialize the language model, the data set called Chat OpenAI data set. We also have another ones for Cohere, for embeddings. But the idea is quite simple. You are able just to set up your language model in the catalog like that and inject their credentials as usual, meaning that you keep the data input set up separate from the credentials and parameters. Another things that I'll need as my input is the system prompt. For that, I'm fine with the text data set because I'll just use it as the plain text. Here they use a very basic prompt explaining that to the language model that it's an agent with the tools enabling to query the vector store, and when it makes sense to do that, because I don't want it to like retrieve and use everything that it got from the context, but decide on whether it relates to the question or not. And the last one bit that I need to save my output is the text dataset as well, but I'll save it in Markdown format in order to make it look nicer. And let's now dive deep into the pipeline, and we'll look at the how the implementation looks like. So first of all, I'll create my tools. That's the function that basically returns the set of callable, because I need to create the function which my agent further can use to call my vector store. For that, I only need the vector store itself and my embedding function. So I'll just explain how to interact with it and how to call it. As a context, I'll use just the first top vector retrieved. For more complex pipelines, you might have some more advanced filtering logic here. Then another part where I'll initialize my language model. I'll need this node because I want to have two models actually, the one without tools and another one with tools, so I could compare them at the end. Then I'll create the chat prompt for my agent. Here, everything is very simple too. I have my system prompt, and I'll inject the input on the fly once I get it from the user. Based on this chat prompt, my model with the tool, I'll create the agent, which basically matches together all this object, my prompt, language model, and it also explains how to fill the placeholders in the prompt. And the last bits are how to basically set up the agent and LLM invoking. And this is where I create those two methods to invoke them. And I'll use those methods to create the interactive loop where basically I'll just query my agent and my language model to get those outputs and then compare them together. So let's go into this pipeline and see how it looks like when I run it. The one small bit is that when I create the agent rec pipeline, I use this stack. That's because I need that the embedding function was also the part of this pipeline, but it also belongs to the create vector store pipeline. I don't want to repeat it. That's why for my vector store, in my vector store pipeline, I tag my embedding function. And if I run the pipelines with the tag agent rec, it will use my agent rec pipeline as well as the function that I need from another one. So let me do exactly this. Don't need this output. So I do Kedro run, and I use a tag agent back. And here I hope to go into the loop where let me do the screen like that. So what I see is like some warnings saying that the default dataset partner was override with some other object, but that's exactly what I need. That means that all those agent, chat prompts and like things that I want to be not serializable, they are passed by the reference, and I don't really need to care about the serialization. Let's ask something like, for example, how can I force node execution order in the Kedro pipeline. And now I expect to see the answer from the plain language model and my agent based on the retrieved context. So here are two answers. First of all, I see my input, and here is the output from language model. Let's see what it says. It says that to force node execution order in the Kedro pipeline, you can use before and after arguments when defining your nodes in the pipeline.py file. That looks nice. It also gives you an example. The problem is that we don't actually have any before and after arguments for the pipeline nodes. So it looks like it got it from some other frameworks and injected into the example for Kedro. So unfortunately, this answer is not relevant. And when you look at the answer for the agent, you'll see that it recommends, first of all, to rely on topological sorting of nodes. So that's exactly what we recommend too. However, it shows that it also suggests to use pass-through nodes in case that you want to force the specific execution. And it shows an example of how to do that, creating some dummy output, which can be input to your node. Okay, this looks all right. The second answer is definitely better than the first one, at least it's relevant. And let's ask something specifically what I use here, because like in my catalog, I use this trick to bypass objects without serialization. So I might ask my language model and the agent how to do that too. So for example, how can I make a copy node assign a default behavior there for Kedro memory dataset. Okay, next time. Here we go. We see that the language model offered the approach where you create the custom memory dataset based on memory dataset. It gave you an example. Basically, you just like redefining your copy mode by creating the dataset on top of it, which is the acceptable solution. It will work. It also touches like what's the default copy mode for the memory dataset, and it's relevant to what it is actually. And our agent offers the approach exactly as I used, where you use this pattern to redefine the memory dataset behavior. This answer is both relevant, but the second one allows you to do that without the implementation any specific custom dataset, so it's just easier. And here I want to stop querying the model and just go and see how the output itself looks like, because I made a markdown to show it. So here you see the output that we just saw in the terminal. The question itself, language model output, and agent output. But what's also important, we see the retrieved context. So what was used by my language, by my agent to answer the question and to suggest the specific answer. And here is the dialogue that was retrieved from the vector store. And we also can see that the intermediate steps that were done by agent. Then what's important here is that it used the tool get context from vector store, and it actually queried my vector store and received the context like this. Those are the main parts that I wanted you to show, and the purpose of it was to highlight that the RAG use case makes sense. It allows you to improve the quality of the answers that you language model may make. And at the same time, you don't need to retrieve it. You can like update your vector store with the very recent replies, in our case, with very recent answers from our question channel, and improve the user experience interacting with those tools. And the second thing is that you definitely can use Kedro with GenAI applications. The trick is to decide how exactly you design it, what will be your date sets. And you can always skip the creation of custom data set by just using the trick where you pass all the objects with the references without serialization. This was the main part. We overrun a little bit, and I hope you have some questions to discuss. Rashida, you're muted.
Sorry. I was just saying thank you so much, Elena. That was a fantastic presentation, incredibly insightful. And now we are open for questions. So please feel free to add any questions you have. We do have a question. Meryl says, "This is so epic. When can we use this to answer real user questions?"
Yeah, that's a good question. We definitely can. Here the question is the budget. So when I implemented this, and now during the demo, I used like my personal training sandbox available at McKinsey. So every query to the model costs something. So if we find a budget for deploying it somewhere, we definitely can. As I said, one of the reasons why I made the vector store in using the very simple embeddings, but not the language model embeddings that might give you like better quality, is because I wanted to minimize my costs. So the question is, if we find a way to do it, it will be great for us and for users, and they definitely have the technical possibility to do that.
Thank you so much. Oh, while you're waiting for other people, okay, Sam. Okay, we have a comment from Sam. Looks great, really interesting. Thank you. Thanks, Sam.
Thank you, Sam.
While another question. How did it feel to use Kedro to build this? Do you feel like Kedro made the demo easier for you in any aspect, or did it give you any extra challenges?
That's a good question, because as a developer of Kedro, I'm not like necessarily the user of Kedro. So like I see it in a very different way sometimes. What I can say, I was thinking that why don't we have the vector store data set? And that's what we are discussing in the team right now. So probably if we had it, the implementation might be a little bit faster and easier for me. And the rest was just to figure out how to bypass this constraint that all the objects need to be serializable. And it can be done with the dataset factories. It's quite simple. You only need 3 lines of code to do that. So there is no any difficulties of using it with language models. The only part that you might like struggle a bit, and where you need some like more engineering like creativity, is when you prepare your data and you parse them, how you work with the multiple files and so on. But again, for this, we have incremental data sets and other data sets that are able to read different formats. So we believe that like more or less we have like a good setup to start building the applications. But again, if you feel something is missing, you can always reach out to us. So we'll just like add things uh, as far as soon as we can.
We have another question by Roman. Just share it. What are the production possibilities of Kedro-based rack projects?
Yeah, that's a good question too. So I would say that the difficulty for production would be to like split your application into this set of different pipelines. Because obviously, when your objects are not serializable, they have to be run on the same in the same container because you won't be able to persist them into some storage and pass from one container to another. So when building the application, you'll have to think of that. But I wouldn't say that's the constraint coming just from Kedro, because if you open like any like LangChain tutorial and you follow it, you'll face exactly the same problem. So I would say like the production won't differ from any other like tool that you'll use for production. So you might get some constraint coming from Kedro, but they won't relate to GenAI application specifically. So if you know how to deploy other application, like following the same approach is fine.
Thanks,
Uh,
Elena. We have one more question. Will the code be, for your example, be available?
yes, it will be. So what we are thinking about is to create the blog post based on this because we want to help users to start with GenAI applications. We want to give like some template of how they might start. So in future, like in a couple of weeks, you'll see those blog posts where we share the code as well. And we also considering creating some starters based on those use cases because now we have like very simple things showed in our starters. And what we thought is might be useful to create like starters like that, where you already have the basic retrieval augmented use case, which you're able to play with and like adjust based on your needs.
Great. Um, yeah, someone who asked the question, Angry Tanko, says thank you as well for your reply.
Yeah,
So
thank you for joining and sharing your interest. That pushes us to improve the features on the Kedro side.
definitely. Since you're over time, let's end the session for now. Thank you all for joining us today. We'll be back in 2 weeks for another exciting session. Please follow us on YouTube and LinkedIn. And that's it. Have a good weekend and see you next time.
Thank you all. Feel free to follow up in the Slack channel if you have any questions. Like, see you all in 2 weeks.
Bye. Thanks,
Bye.
Elena.
Thank you.